Get away. Perfect. So Doug mentioned some core values that Skyport gives you. I'm really going to talk about two of them. The first one is really the most interesting one to me from a security point of view. We'll spend plenty of time talking about how we do awesome things security-wise. But one of the toughest problems you're actually trying to solve is, how do you know you got it right? This is the toughest part about security that's very different from traditional networking. Networking, you can test it. You can test it and see that it doesn't break the way you weren't expecting it to. But security is very hard to prove that you got things right. So a large part of what we've built into Skyport is a way that you can deliver secure services and know that they're delivered correctly every time. For some things like hardening the platform itself, that's an inherent part of our system. So let's talk about that first. Let's say you have to deploy a server out there in front of your firewall, and it's got your passwords to your retirement account on it. So let's up the stakes a little bit. What do you need to do to make sure that that platform is hardened, to make sure that the system running inside that platform is hardened? What are all the steps that you would take, and how would you know that you got it right? Well, with Skyport, we solve the first problem, at least on the platform side, and we make it ridiculously easy. So the first thing you notice when you work with Skyport is the actual appliance model allows us to very easily deploy a system and very easily give you the answer, did you get it right? In fact, you plug in a box, you give it power and Ethernet, and you're done. We just did this last night. I was up late last night working with a financial customer. They had a deadline, they had to get a new appliance in before midnight, and we got it in. And the reason we got it in was it was really simple. We knew that we had to put a device into a secured environment of a financial company going into tax season, and we knew that this had to come up, we had to verify that it was known good, and that the platform was hardened. And we're able to do this because of the deployment model. It was very simple. We add Ethernet and power. It communicates to our service, just like Doug was talking to you about, and in the end, what you're looking for is okay. What this tells you is we've done a series of measurements on the platform. We know that it's running known good hardware, known good firmware, and known software. Another part that we've built into this, though, is it's not just trust. It's also trust but verify. And you find this happening consistently throughout the platform. How do you know? Well, I can actually show you the individual PCR registers if you want to get really geeky on what we validated here. In the end, validating a hardware platform should be invisible. This is what should make it as easy as deploying an Xbox. This is something you shouldn't have to think about. With Skyport, you get this out of the box. So now the next thing, let's look at what it takes to roll out a workload securely. And if you start looking at the UI, what we've actually done is something relatively unique for a security company. We try to make this as simple as possible. There's a lot of knobs. We can do very cool stuff, and we'll walk through some of that as part of the demo. But the goal here is we don't force you to set the knobs correctly every time. And the real problem is when you start handing off access to your ops teams to roll out a system, how do you know that they set the right knobs correctly every single time? That's what we've also built into Skyport. It's one of the reasons why we're delivering management of the workflow of the system as well. This is why we've converged security, virtualization, and even network functionality inside a box. In fact, rolling out a new workload can be as simple as 2 clicks. Here we've already published a couple apps. Let's roll out a Windows workload. Let's say that this is your corporate image. This is your known good corporate image. This is the one that your systems team has built, and you're going to use this to build each one of your new applications. When I roll this out, the system is dynamically configuring the complex components behind this. We're automatically building that software-defined DMZ environment around the VM. You don't have to do complex network configuration. In fact, we've built a software-defined network that's actually delivered significant protections against a bunch of network layer attacks. It's automatically built. You never had to do a thing. In the end, we've automatically programmed in a known good golden image. In order to have a secure system, you have to start with known good. We actually build in that validation inside the system as part of the VM. But the thing that's unique about SkySecure is that security policy and that network policy around the VM is actually part of the same configuration. It sounds relatively obvious, but the important part here is it means you cannot roll out a VM without a security policy. And here, I didn't have to specify anything. For this known good corporate image, this image may have been built 12, 24 months ago. It's common that you can have an old image that you're building onto, but the problem is now you've got over a year of known vulnerabilities that you have to patch. How can you bring this up in a secure environment, allow it to patch itself, and then prove that nothing has compromised it until then? That's actually what's built directly into SkySecure. So not only did we validate a known image, we've also set a policy by default around this that guarantees that nothing can get in unless we've specifically allowed it. We build this directly around the VM. This is actually the answer to the other question about deploying this in a DMZ. Even if you have advanced firewalls at the edge, they can only see traffic that passes through that network perimeter. In this case, we can see traffic and all traffic that goes into and out of the VMs, even between these VMs. So it's actually a completely separate perimeter. If you have a machine that's owned inside of your DMZ, we can actually stop and limit that attack because of where we put this perimeter. We've also locked down external access, so it can only connect to Microsoft Windows Update or WSUS or Microsoft Activation Services. So we're actually limiting all the communications into and out of the VM as soon as you bring this up. This is actually how you can guarantee a secure birth for this system. How do you bring up this image, bring it up to a current patch level, and then be able to know that in that period while you were patching it, it didn't go to anywhere that it shouldn't, and nobody reached in and communicated with this system that shouldn't talk to it. This is actually what's fundamentally built in inside of SkySecure. Once it's up, though, this is where things get more interesting. Let's say that this is an Active Directory server. Long part of the hardening list of AD for all the things you should do in AD, but there's a bunch of fine print that says you have to build on a known good secure platform. In fact, if somebody owns the underlying Windows OS, they own Active Directory no matter how well you've locked down that system. Once you deploy AD, we can start off and give you the assurance that it's a known good platform. But on top of that, now, what is the correct policy that you set for an Active Directory server? Have you guys set firewall policy for an AD box? It's kind of hideous. There's a whole laundry list of protocols and dynamic port numbers you have to allow into and out. The next thing we're doing is we're simplifying this best practice. It's actually a single button. We enabled a single Active Directory policy where we collapse all that complexity into one server role. Again, the goal here is how do you know you got it right, and how do you know that if you delegate this to another team that they're going to get it right every single time?
So that that policy is built in, or is that something that's defined by the customer when they so I mean, I guess, are you providing known good, policies to say that I'm deploying Active Directory for the first time. I haven't had to go through this process before. I just click this button and it says all these ports are what's supposed to be in, or does the customer have to define what the policy is going to be, then it gets stored and reused later?
So this is actually something that we're defining. This is an entitlement that's basically for a server role where we collapse and maintain all of those permissions, and we dynamically keep that up to date. The other thing that you get from this is it's always consistently kept up to date. You're not managing individual pieces of software or code revs or configuration drift inside the system. So not only do you have an easy button for Active Directory policy, we continually keep that up to date. If Microsoft opens up new port ranges, opens up new protocols, we can dynamically update that as part of the service.
I was curious about that, specifically in and around compliance-based environments. So there's been some conversation going on about things like PCI and things like those types of environments. So being able to say, standard says this, that's what we know we need to secure to, being able to validate right out of the box that this policy meets those requirements and just able to push it straight, make it happen. I mean, for environments that don't have security at its core, to be able to provide an environment where you can just push that, it's a nice feature.
Did you look at the demo script? Because that's actually what I was about to show you.
I'm sorry, I don't mean to.
So this is actually the key. How do we make it simple, but at the same time, there's a validation? How do you trust but validate that policy? So if you put these rules in a firewall, how do you know that these rules are taking effect correctly? The next thing that we've built into this security perimeter, as Doug talked about, is traffic visibility. The key thing about how we've designed this is, first, we never trust the VM. The VM can do whatever it likes. We intercept everything as part of a network path, and we build into hardware that network path. There's no way the VM can send out a packet without us seeing it, and there's no way the VM can send out a packet without us being able to apply policy to it. Now, once you couple visibility with policy enforcement, you get some really powerful tools. What I'm showing you here is an output of this traffic intelligence report. At first, it looks a little strange, but it's actually really easy to read. You actually read it left to right. And this is designed to visualize a whole bunch of information and make it very easy to see what's going on. You read it left to right, it's everything coming to and from this Active Directory system. So this is a 2008 server running Active Directory. It's a domain controller. We can show you directionality of the actual policy. We can also show you which individual services are here, who it's talking to, and we can add a key point of information. We can tell you what's allowed. What you're actually looking at, by the way, is a report that shows me only traffic from this Active Directory server and only traffic that actually matches this AD policy that we just set. This is the trust but verify component. And this is what allows you to validate that the policies you set not only are right, but they're being enforced correctly. This report is actually showing you all the traffic in the past week that actually matched that policy. This is a live system. This is real traffic.
That's what I was going to ask.
So this is actually a real SkySecure server running real VMs in our demo environment. The other interesting sidebar I'll note here is because it's a hardware platform, it's also designed for 100% remote management. I've never seen or touched this box. It's located in a remote facility. And we've built in all of the functionality for me to not only administrate, but audit and validate every function of that system without ever having to touch it. When you start thinking about branch office scenarios, imagine the power where you could actually deploy a known good platform and never have to touch it. You can actually have smart hands plug it in and know that you never have to go in there and actually access that system for any troubleshooting or policy validation. In fact, in this remote site, I can prove that this AD policy is working, and I can show you everything that it matched. This is also dynamic. I can start breaking out addresses and ports, and in real time, it's going to come back and show me the results of these policies. The next thing you probably want to know is what didn't match that policy. Well, there you go. Quite a bit. It's about a week's worth of traffic, so we'll cut it down a little bit, but it's actually showing you quite a detailed view of everything that's going through the system. In fact, these are all the ports that were not covered by this policy. This is your audit trail. Imagine that you're now being subject to audit. You can go in and prove that you've had firewall policies in the system and that those policies haven't changed. What you can't prove is that the packets went through the firewall, they didn't have another way to go. And two, it's very difficult to actually produce a report saying, these policies were effective, and here's everything that it did allow, and here's everything that it did block. And by the way, we know for every flow whether it was allowed or blocked.
And this is the same direction, right? This is still traffic from that server. This is just junk it's trying to send out.
This is actually both direction. I can even restrict it more. So this is everything not matching the policy. That policy was an inbound policy. So a hit was only things in. And now I'm showing you everything that wasn't that policy. So it's traffic in both directions. But you can filter it down to each one of these views. Just to give you an idea of the type of data that we're actually doing, think of this as a visualization tool. I'm going to run a query that is going to give us much more granular detail. This is the level of detail we see. This is what we're helping you visualize. You can actually get down to the point where you can account for every flow, how many bytes and packets went through the system, whether it was allowed, whether it was denied, and what policy allowed that through.
So I can take that known good image that we just deployed, and I can look at the traffic that's coming out of it to see what Windows is doing that it shouldn't be doing based on my known good image.
Absolutely.
And it's getting blocked anyhow because of our policy, but I can still look at that.
Precisely. And in fact, I'm going to run a report right now that says, show me all traffic in the past hour. So one of the pieces of magic in this system is the reporting and also the security data warehouse in the background. We've split the load here. One of the first questions we often get is, well, how much space do you have on your server that you can store this amount of detail? No matter what, that's a losing proposition for this type of information. You want to have two things. You want to have an extensive audit log, and you want to have the ability to query that very quickly. You see how quickly this comes back. This is working on a year's worth of data, of granular data for all the communications on that system, and we can return a query that quick. This is because of the infrastructure that we've built into SkySecure Center. It's not only the scalability, but it's also the ability to query that quickly. So I talked about how easy it was to deploy a box. There's one other thing you get for SkySecure, though. If you were going to build this yourself, it's not just the software packages that you would run on the server. It's all the back-end services that you would have to run. If you're running a virtualization system, you have a hypervisor orchestration system. You can call it vCenter, or you can call it Zen Server Manager, or whatever you'd like. But each one of these is now a service that your ops team needs to run. You start adding things like microsegmentation, distributed firewalling manager. That's a separate service. Your ops team now has another service they have to run. And running it doesn't mean just making sure it stays up and stays green. Running it also means applying patches, keeping it up to date, configuring it correctly, and scaling it. What you get from SkySecure is all of those are delivered as part of a service. This is no longer a problem for your ops team. You can deliver this level of assurance and not add workload to their plate to get this level of analytics or scale.
I'm unclear on something here. Where's the log data being kept? The information that you're showing here?
Yeah, that's a great question. So the logging data.
And how do I know it's secure?
Yes.
Where's my...
Is it running on your own systems in the cloud?
Yeah.
Yes. So there's a couple answers to that, and I'll let Rob jump in when I say something that's not clear enough. So we're doing two things. We're separating out the problem of how do we capture the information accurately, and how do we make sure that's part of the data path. This super NIC that we showed you, part of what the functionality that we've built inside of this is not just the software-defined networking and also the policy, but it's also accounting for the traffic data. So the sampling is actually happening in the hardware path. So all packets that go out of every VM pass through this I/O controller, and we're doing the sampling and aggregation locally on the system. Now, we're not storing the data here. We're caching it until we can send it up to SkySecure Center. There's a service component for this. As Doug showed you, the security data warehouse, the real-time processing system, this is the back end where the data goes. This is where we can give you an extensive volume of data that we can query, as well as a real-time query system. So I can go back and give you these reports back in real time. This is also continuously operating. So sampling happens locally. The metadata of these packets, you can think of it conceptually as NetFlow with additional information about, for instance, policies and also whether it was allowed or denied. That data is sent to the service, but your packets or your VM data always stay local inside the server. So your exposure is not really any different than sort of exporting NetFlow data.
One question about storing the VM images. Are they stored somewhere on the box?
They are, in fact. We've got a couple options. So inside the system, we've designed it to be a fully turnkey environment. So the nice thing here is you can use this without having to integrate this into other systems in your environment. So we give you two options of where you can put a VM. In this case, in this demo environment, we're using the onboard storage. So we have onboard SSD. It gives you a couple advantages. One, it's inside the system.
Yep.
It's fast I/O access because it's SSD. It's also redundant.
Yep.
But also, every VM is kept in a separate encrypted volume, and the encryption for that is actually tied to the TPM. The reason you care about this is when you're hosting Active Directory, I can actually provide guarantees that even if somebody physically steals your server, they cannot pull off that virtual hard disk, which has your NTFS DID, which has all of the secrets inside that Active Directory server. And also, because we control access to this, anytime you're backing up the data from this encrypted volume, it's authenticated by our system and audited. So we can give you a very strong data at rest protection for anything running inside.
Are customers asking you about storage arrays, external storage arrays?
Certainly. We offer different options for running VMs. So if integrity of the VM is important, you would import that inside the local system. Today, we can also run it in place from an NFS share outside the system. We've also had requests for other types of storage access, things like block storage access. Today it's NFS. The way the system works is this is very loosely coupled to how we deliver the protections. These are changes we can make in software, and it's a question of sort of what's the use case, what's the market.
Right. So you can refer to an external storage array if you need storage, bulk storage of some.
Indeed, I can actually run this in place from a remote NFS store. That's particularly interesting if you have a huge data volume, if you want to make sure that you can back that up remotely or fail it over from one system to another.
Two quick clarifications, if you don't mind. First, so you talked earlier about app-aware firewall policy, but it looked like some of the stuff you were doing in here was based on just like TCP ports.
Yes.
Okay, so are there app signatures, or is that handled in a different component, or where does that come in?
We actually do both, and it's really a question of how we report on the data. So everything that you're seeing here is designed to answer the question, what's going on? And the answer to what's going on should include information about all the observed flows as well as flows that are going through application layer gateways. So this is actually a union of those. So all flows are actually shown here in the traffic intelligence report. And in fact, what you can start to see, this is a different VM that's been up and running for a little bit. This one is actually showing you a little bit more information. And part of what we export as part of these records is not just what flows did we see and were they allowed or denied. We also include information about what policy allowed or denied them. We have a unified policy language that governs both things like traditional firewall policies as well as layer 7 application proxies. So each one of these, you can actually trace back this policy to exactly what type of entitlement this was. This could be a layer 7 proxy, this could be a firewall entitlement, or this could be a server role entitlement like AD. And that's all traced back to the flow.
Gotcha.
And you have ways of auditing the policies to determine that policy X had never been hit in, say, the last 30 days, so maybe I need to go take a look at the policies I have defined.
That's actually a key part of what we've built into the system. So one of the questions is, how do we deal with logging and what's the value of having all this data in one place? If you go back to really what's the core question we're answering is, did you get the security policy right and can you prove it? One of the key things we've done is we've integrated these all together. And you see little footprints of this, and I'll tie this together. Part of it is the traffic intelligence display. This display that I showed you, by the way, is actually a detailed view of everything this VM did in one time slice, and I can show you what policy was in effect at the time that actually allowed or denied this traffic. So this is actually temporally aware. I can also go back to the policy definition. This has more policies that have a more interesting lifetime. So in this case, if I want to look at a policy, let's go find a good one here. Here is a web-in policy. So here, this is a layer 7 entitlement. It actually has a full lifetime. And this is actually tied directly to the actual VM, as well as the users in the service, as well as all of the events tied to it. So I can actually go back in time and show you back to point of inception when this policy was built, who made changes, when those changes happened, and what those changes were. And that traces back to the original inception of the VM. So what we're maintaining is a life cycle of the server. Inside of that, we're also maintaining a life cycle of every virtual machine in the system, every policy associated with that virtual machine. I can tell you a detailed record of who changed what, when, and where, and I can tie the individual traffic that matched the policy at the time, all in one system.
So, again, can I take a look at this and say, show me all the policies that had no invocations? I saw no traffic against this set of policies. Show me all of those policies.
I'm trying to think if that's an easy, so the answer is yes, we can give you that report. I'm trying to think if we built an easy way to get that in the UI today. The one little trick, by the way, is the UI.
Because that may mean that I have a policy wrong. I've done
Absolutely.
something wrong there because it's not being tripped by any traffic for the last 30 days, let's say, or even today.
Absolutely, and we can actually build that out. So I can go here and specify a filter for individual entitlements. I can also specify a filter for whether traffic was blocked or allowed by the entitlement. So all of this data is actually queryable inside the system. And on top of this, everything that you see here is actually an API call. The entire client that you see is actually an API client. So this is also something that you can actually automate directly. Our goal here is to first and foremost make it easy. So we can show you and give you effective control and reporting on the system out of the box. But once you start using this, every mouse click that I've done here is something you can do through an API call. You can control.
REST API, I assume?
It's a RESTful API. It's largely based on JSON. I won't bore you with the gory details here, but if you want to see it later, I'll actually show you what that API call looks like. I promise to show them two specific things in terms of proxies, so let me go through and make sure we get through that first. We were talking about the web demo. Let me actually show you what that looks like. So this is an Ubuntu virtual machine running inside the system, and we've crafted a policy here that actually controls inbound web access. Now this is a full proxy entitlement. What this is doing is presenting a secure HTTP session to the outside world. This is a TLS 1.2 session. Inside, the VM itself is actually speaking an unencrypted web server process at port 80. In fact, It's actually running in this other tab here. If I refresh this now, what you actually see is this is the web page coming from that unencrypted Ubuntu instance or Apache instance on the inside. To the outside world, this is actually, it's probably a little hard to see, but it actually says this is TLS 1.2, and we've mandated a strong set of ciphers. The reason you care about this, as we talked about before, is not only can we manage the certificate as part of this, we can also remediate vulnerabilities. S-channel is one of these vulnerabilities, 14066. This is one of the things that we can actually remediate. Also in a DMZ environment, because this wraps around the VM itself, it actually applies even between systems inside the same DMZ. So this gives you a layer of protection against lateral attack. We did also talk a little bit about some of the application layer controls. I'm going to show you one. This is sort of a little bit on the geeky side, but it's really powerful. Inside the same virtual machine, I've crafted another policy here. And this one actually controls SSH. And what this is allowing me to do is a couple things. First of all, I can show you a lifetime of when this went in and what changes happened. But also, as I dig into the policy, you can actually see what we can control in SSH. This is actually going to intercept outbound SSH traffic. This is actually, ironically, more valuable than inbound. Outbound SSH traffic is what you use for things like DevOps automation suites, SaltStack, Ansible, things that reach out over SSH and talk to your infrastructure. Even something like Rancid that's archiving router configs needs to reach out over SSH. What you can now do is craft a policy entitlement that allows you to connect to an external resource. It can substitute the actual credentials. So here the real account is demo, and I'm going to create a new credential on the inside. So let's watch what happens. If I SSH, I'm going to go to a NFS server that's running outside the compartment. And I just typed the right password. That is actually the correct password to log in. You can trust me, or I can show you later it's actually the right one. Because we've actually intercepted this SSH connection and blocked it. That password is not valid inside our system. In fact, I've created a separate user ID here. This one's really simple because it's easy to type, so I'm going to call this one Canary. If I log in as Canary, that actually unlocked the real user ID to access the external system.
And passed it.
This is a locally significant credential. The reason I called it Canary, as Doug mentioned, is now this only exists inside the compartment, which is great for protection. And you've also hidden this SSH key from the outside. But now if this is ever stolen, you know where it was stolen from and that it should never be allowed to exist. On top of this, the other thing that I showed you here is we can also even control individual parts of the SSH protocol. I've actually blocked everything but interactive mode. If I try to SFTP or SCP or try to set up a tunnel in SSH, we'll block that. And as part of the policy engine around the system, if I try to go around this, I can automatically drop it. And as we talked about before, what I can also even do is mirror these packets in real time. And in fact, this is actually part of the system that we've set up. Anything that's not matching policy, I can give you a live feed of these packets. So these are all the things that we've actually built into the system. I won't go too much more in detail. We can go into specifics if you'd like to see them during lunch. But all of these functions are actually built into the system. You didn't have to install software packages. You didn't have to do extensive configuration. It's ready to go. And the configuration for all of these protections are actually tied directly into the VM.
So I see, as far as configuring policies, I see that it looks like there's two types. There's the types that I can go in and configure, and then it tracks when the policy was created, who changed it, all that stuff. Mm-hmm. And then there's a policy like the AD policy that is the single touch. Well, this is AD, and you already know what should be in there. Mm-hmm. Is that right? Those are the two types of policies that, in general, that we can have that you have in Skyport.
It's actually even a little bit more than that. Every part of configuration for us is effectively a security policy. I'm getting the wrap-up signal, so I'll answer these if you guys want to come up. Okay. Everything that we have is a security policy, and we track the lifetime the same way, and we can track it back to traffic the same way. Okay. Underneath this, a policy can do different things. I can create a policy that is a composite of multiple traffic entitlements. Something like AD is actually going to open up a significant amount of protocols underneath and do that dynamically, and we can update that list and keep that up to date. Basically, we can control the complexity of it.
Okay.
We can also have another policy that is a simple firewall policy. And we could also create policies that create application level entitlements. And the entire goal here is what we're trying to do is make the concept of what a policy looks like simple and auditable. So the way you actually read this is first you set a default compartment policy. Anything that doesn't match these whitelist policies, this is what to do with it.
Gotcha.
And then you specifically allow in traffic. And what this is designed to do is make it very quick and simple to go through and see what is configured and audit that each one of these permissions is allowing in only what you want to allow in.
Okay.
And we've given you a way that you can deploy this. So first, open access, then add policies, observe the traffic that doesn't match the policy or matches those policies. Once you're comfortable with it, then start looking at traffic that doesn't match your whitelist entitlements, and then finally flip it over to full whitelist enforcement where you drop all other traffic. At that point, it's actually a very easy series of steps, and you can keep the same forensics log, so you're never in the dark about what you could be dropping as you move towards this full whitelist entitlement.
Okay.
So with all these policies, how do I manage the library of policies?
So there's a couple things that we've built into this. One of which is the concept of a template. So we skipped over it a little bit in the beginning, but it's the ability to publish a set of policy entitlements with an application template. So the idea here is you can actually build and maintain a policy set for a known service in your environment and have a single click to roll that out. And what you'll see over time is we'll be adding more and more layers in terms of more detailed policies and groups of policies that you can start to share between different systems.